Students, so let us move on to the next module number 4. In this particular module number 4, there are two topics: support reactions, particularly associated with respect to beams, and also analysis of trusses. Here you are having two topics: beams, trusses. There are two topics, beams and trusses. What are the expected questions in VTU examination? It's a very important thing, and it's a very simplest module compared to all modules. Especially numericals are very simple in this particular module. What are the theory questions expected in this particular module? The very first theory question is define beam. Define beam. What are the different types of beams? Different types of beams. Explain with neat sketches. Explain with neat sketches. Explain with neat sketches. With neat sketches, explain different types of supports. Different types of supports. Third one, differentiate, explain the difference between statically determinate and statically indeterminate beams. Statically determinate and indeterminate beams. Indeterminate beams. Explain with neat sketch different types of loadings. Types of transverse loads on beams. And the very last question is define truss. Explain different types of trusses. List the assumptions made in truss analysis. So, in entire fourth module, these are the possible theory questions. Only 6 questions. We'll go one by one. Define beam. What are the different types of beam? Explain with neat sketches. The beams are nothing but it's a one-dimensional structural member. What is meant by one-dimensional structural member? One-dimensional structural member means the length of the beam is more compared to other two cross-sectional area. See, here the length is large. Length is large compared to breadth and depth. So beams are nothing but it's a one-dimensional structural elements and having ability to take a transverse loads from the members. And what are the different types of beams? Depending on support conditions, the beams are classified, and also with respect to equilibrium condition. So to justify this answer, we must know what are the different kinds of supports. So any beam is rest on supports. There are different kinds of supports. This is called simple support. This is called simple support. This is called hinge support. This is called hinge support. And this is called fixed support. It's called fixed support. Fixed support. And also one more we are having, that is called roller support. This is called roller support. So what are the different kinds of supports? The different kinds of supports are hinge. Hinge are having two reactions. The possible reactions at hinges are two, purely vertical and horizontal. Simple support comprises of only one vertical reaction. Fixity having three reactions, one vertical, one horizontal, and one rotation. And roller is also having only one vertical reaction. Roller is one vertical reaction. So depending on this, we can classify the beam. What are the different types of beam? The beams once again is classified depending on equations of equilibrium. Equations of equilibrium. What are equations of equilibrium? Sigma fx equals 0, sigma fy equals 0, and sigma m equals 0. There are three equations of equilibrium. The beam which can be analyzed with the help of these equations of equilibrium, we term it as statically determinate beams. We term it as statically determinate beams. The beams which can be analyzed with the help of equations of equilibrium is termed as statically determinate beams. What are the examples? What are the examples? Simply supported beam, simply supported beam, cantilever beam, cantilever beam, cantilever beam. What is meant by simply supported beam? The beam rests on two simple support. The beam rests on two simple support means how many reactions? 1, 2. Only two reactions. Available equations are 3. Hence, this beam is a statically determinate. Similarly, fixity. How many reactions? 3. Available equations 3. This is also statically determinate. What are the statically indeterminate? The beam cannot be analyzed with the help of equations of equilibriums alone, which requires additional compatibility conditions and boundary conditions. So those kinds of beams are termed as statically indeterminate. What are the examples? These are statically determinate. Statically determinate. Determinate. The example for statically indeterminate. Statically indeterminate. Statically indeterminate means the beams which cannot be analyzed with the help of equations of equilibrium alone. So the example is propped cantilever. Propped cantilever. Fixity 3 reactions. Here simple, total 4. But available equations are only 3. Hence, this propped cantilever beam is statically indeterminate. Fixed beam. Fixed beam. Fixed beam. Fixed beam. Fixed beam is also statically indeterminate. Why? 3 plus 3, 6. Available equations are only 3. Available equations are only 3. And also continuous. The beam having more than one span. 3 plus 1 plus 1, 5. Available equations are 3. This is continuous beam. Continuous beam. So these are different kinds of beams. With neat sketches you have to explain one by one. So the beams are classified with respect to equations of equilibrium. Depending on equations of equilibrium, the beams are classified as statically determinate, statically indeterminate. The beam which can be analyzed with the help of equations of equilibrium or equations of statics alone is called statically determinate beams. Example, simply supported beam, cantilever beam. The beams which cannot be analyzed with the help of equations of statics alone, it requires extra compatibility conditions or additional equations. Those types of beams are referred as statically indeterminate beams. Example, propped cantilever. Here 4. Available equations are only 3. Here 3 plus 3 6. Available equations are only 3. Here 3 plus 2 5. Available equations are 3. So the answer for this particular question. Explain with need sketches. This is very important question. The next question, with the need sketches, explain different types of supports. I have already explained. Hinge is one type of support. There are two translations, one vertical, one horizontal. Simple support, only one vertical reaction. Fixed support, there are three, one vertical, one horizontal, and moment. Roller, only one. So these are different kinds of supports. The third question, explain the difference between statically determinate and statically indeterminate beam. I have explained statically determinate means the beam which can be analyzed with the help of equations of statics alone. The beam which cannot be analyzed with the help of statics, statically indeterminate. With example, you have to list. Next, explain need sketches different possible types of transverse load. The loads can act in transverse direction, perpendicular. What are the different types of loads? It's very important. The first is point load. Point load. If it's a beam, the point load may be inclined or purely vertical. This is point load or concentrated load. The second one is uniformly distributed load. Uniformly distributed load. Uniformly distributed load. WL. The load acting throughout same. That is uniformly distributed load. And if you have to convert this UDL into point load, it's very simple. W into L acts at L by 2 for UDL. This is for UDL. Next, uniformly varying load. Uniformly varying load or triangular types of load like this. Uniformly varying load. WL. WL by 2. 2/3 of length from apex, 1/3 of length from base. 2/3 of length from apex, 1/3 of length from base. This is uniformly varying loads. These are different types of possible loads. With additional, you are having couples or moments. Couples or moments. Clockwise couple and anti-clockwise couple. These are all theory questions associated with beams. The next question is define truss. Explain different types of trusses. Truss is a triangular elements, especially steel elements in sometimes. Generally there are steel elements and having area of same area and fractional rigidity throughout the members and pin supported members at joints. Truss or pin joints, pin supported members. So triangular elements, pin supported at joints. So are trusses, pin joints, hinges. And explain different types of trusses. Once again, depending on M equal 2j minus r equation, trusses can be classified as perfect truss if the equation obeys M equals 2j minus r, then the truss is termed as perfect truss. For an example, if you consider one truss, hinge, if you observe how many members, 1, 2, 3, 4, 5 members. How many joints? 1, 2, 3, 4 joints. How many external support reactions? Here 1, 2, 3. So M equal to j minus r. M is 5. 2 into joint is 4 minus 3. 5 equals 5. So this truss is perfect truss. Truss is perfect truss. So if M greater than 2j minus r, then we term as redundant truss. Redundant truss. So, matlab M is more. So, you have to write one more member. So, it is redundant truss. Redundant truss. If M is less than 2j minus r, then deficient truss. Deficient truss. Deficient truss. So, you have to remove these two members. Now, M less than 2j minus r. That is deficient truss. There are three kinds of trusses. If M equal to J minus R, perfect truss. M greater than to J minus R, redundant. M less than to J minus R, deficient. So this is regarding theoretical questions associated with module number 4. It's a very easiest thing. So in next class, next session of video series, we are going to discuss regarding numericals. Thank you.